So we start with the first few slides. First of all, we have a little bit of housekeeping. During the webinar, please switch off your microphones, switch off your cameras, so the bandwidth is not is not suffering too much. The measurement duration is the webinar duration is actually planned for 15 minutes, and then we have 10 minutes for Q&A. For the Q&A, please post your questions into the chat of the team session. The Q&A session will be on the end of the webinar. We will moderate the Q&A session. So we gather the questions, and the same questions will be answered at once. If we are running out of time, unanswered questions get answered in a separate email after the webinar, but we try to cover all the questions, of course, during the webinar. And we hope in the end of the webinar, actually, you have no questions anymore and everything is answered. So that's to the housekeeping. So we go a slide further. As I said, we welcome you to the first lesson of our RQ webinar course with the topic basically general information, products, and choosing the right instrument for the right application. This means we will see through the presentation, we will see a couple of different products which are there for different users. And in the end of the presentation, we see, or we concentrate us more on the RQ. And as soon as we are concentrated on the RQ, we will go through a couple of application pictures today, a couple of applications, how to mount it, where to mount it, how to install it. Today's webinar will be about the surveying of the cross sections. And after that, we will go to the Q Commander software, how to input the profiles, and covering the most of the questions normally we get asked. On Friday, that's on Friday, and on Tuesday next week, we have a presentation about site selection. So we are in a very interesting topic this week, and the webinars are all with a very special focus on RQ and how to deploy an RQ. And actually all of the webinars are quite a necessity to set up an RQ and can help you quite a lot. So first of all, most of you don't know the company. Sommer is an Austrian company founded in 1978, so more than 30 years old. We have more than 30 years of experience in the meantime in developing hydrological and meteorological instruments, and we are focusing on high quality products, very robust products, and with a special focus, of course, in hydrology on non-contact measurements, providing you the best in class technology for the future. So today we go forward on the product folio. We concentrate ourselves on hydrology. So here we see we have instruments for discharge, we have instruments for level, surface velocity, measurement of open rivers, open water, of surface water. So the focus is today here. And if we continue now, I hand over the presentation of the webinar to actually Johannes. He is responsible for the trainings here in Sommer, and he is basically doing the most of the trainings we are offering. Normally, he would welcome you here in Austria at our company, but today we have to do it online. So let's give it a chance and give it a try. So I hand over to Johannes, and he will take care about you.
Okay, thank you very much, Christoph. Yes, hello to everybody far away in India. I'm trying today to guide you through the application of the RQ instruments, and we are just starting with some basic information about our contact-free, non-contact measurements. So generally, what are the advantages of our contact-free measurement with our discharge instrument RQ30? It's easy. Oops. I'll go back to the slide again. Sorry. It's easy to install and we have high reliability impaired by any installations within the water. And it's safe from flotsam, trees, debris, bad load, all the things that might disturb some measurements. And the RQ30 has the advantage that the discharge calculation is already done within the sensor. So we plug in the sensor and we right away get the discharge of our river. So what are the principles of our non-contact measurements? We have two parts in our RQ30 instrument, and that is, first of all, the water level sensor, which we can see here underneath or at the bottom of the instrument. It is a radar instrument and is based on the transit time of a radar signal. We use 26 gigahertz signal that is sent out as an impulse to the water surface. On the water surface, the impulse is reflected and the RQ30 registers the reflected signal. And the time that is required for the signal to travel to the water surface and back again to the instrument, that is proportional to the distance and consequently to the water level. The radar has a big advantage that it is independent of air temperature and of the medium. So at some rivers, like with a large humic load, we might have foam on the water surface, and using a radar instrument prevents reflections from the foam, and we can really see the water surface. So it's independent of any foam forming on the surface. In our product range, we also have an ultrasonic level sensor available. Essentially, it is based on the same principle, except that it uses ultrasonic instead of a radar signal. Again, we send out an ultrasonic impulse to the water surface. It's reflected again and detected by the sensor, and the transmission time is proportional to the distance to the water surface. As the signal of an ultrasonic sensor is temperature dependent, we have a temperature measurement included, and it's compensated for any temperature influence. And as it has no moving parts, it is also maintenance free. All right, then the second part of our RQ30 instrument is the velocity sensor at the front of the instrument. And this sensor is based on a frequency shift of a radar signal. So the RQ30 sends out a signal at 24 gigahertz, and it is reflected at the water surface. And when it is reflected, the frequency of the signal changes. And the intensity by which it is changed is proportional to the flow velocity of the water surface. So by knowing the velocity and the level, we can apply a hydrologic model that is stored within the sensor, and we can calculate the discharge of our river. One note maybe, this velocity sensor in the RQ30 instrument has been certified by the Swiss Federal Office of Metrology So this confirms that we have a very accurate instrument for use in the field. So with the RQ30 instrument, we have measured the water level with radar or with ultrasonic signals, and we have a velocity. And from the surface velocity and the cross-sectional area of our river, we can calculate the discharge of the river. And in this formula, where we calculate the discharge, we have the mean velocity. The mean velocity is somewhere in the water body, and this mean velocity is calculated from the local velocity at the water surface. So V local is the velocity measured by the RQ30 at the water surface. This is multiplied by the so-called K value and the cross-sectional area. Further details about this equation is coming up in the next lessons, and we'll get a better idea how to calculate the cross-sectional area and how to deal with the K factor. But for now, essentially, we are measuring the water level, we are measuring the local flow velocity, we have the K factor and the cross-sectional profile, which are programmed into the instrument. And from these four variables, we calculate the mean velocity, the cross-sectional area, and again, from these two results, we get the total discharge of the river. So what is actually the difference to conventional discharge measurements, which are basically based on the water level with a rating curve? So we have here on the left side some information on discharge measurement with classical methods, and on the right side with our contact-free RQ30 method. With the conventional method, we have, it might look that the investment costs are pretty low. On the other hand, you have a quite high initial cost buying the instrument, the RQ30, for the measurement site. But then it takes a lot of time to calculate the discharge curve, or to draw the rating curve, because you have to go out in the field many times and at different water levels, record the water level and fill in the rating curve of this method. And this might take up to 2 years to get an accurate rating curve. On the other hand, with an RQ30, we can install the instrument right away, and the instrument gives us the discharge continuously every few minutes, and it builds a rating curve much, much faster, and maybe takes just a few days or weeks to establish the complete curve. And the classical method uses only the water level, and water level alone gives us only limited information about the flow conditions we have in the river. On the other hand, the RQ30 measures the water level and the velocity to calculate the discharge. And these two variables, level and velocity, have a much more bigger potential to give us information about the flow conditions in the river, like a riverbed change or hysteresis effects and the like. And what is the difference as well? If a riverbed changes, we need a new rating curve. So with the classical method, a new rating curve means, again, a long time until we get accurate discharge measurements. And with the RQ30 method, we just measure out the new cross-section, do a new river survey, and program it into the instrument, and we're done, and we let the instrument do the work by itself. And another advantage of the RQ30 method is because, as I mentioned before, because we have the velocity information, we get much more information for flood warning. I will show you an example here coming up. So here is a comparison about data acquired by a classical method. Here a rating curve, the red line done with singular measurements at the measurement site, the red line, and the blue dots are the RQ data gained automatically from the instrument. And we can see that those lines match very well, except that the red line takes a much longer time, up to 2 years, to generate. And the rating curve done with the RQ system might be built within a few weeks. So here is an example about flood detection or flood warning. So in June 2050, a heavy rainfall from the tropical storm Bill destroyed a large campground in the US. And from that point on, the NOAA realized that they need an advanced system to give more precise flood warnings at exposed sites, and it introduced the sensors that also measure flow velocity. And so in 2017, an RQ30 was installed at Falls Creek, where the tropical storm was devastating the campground. And when the next flash flood happened, the data were recorded again. And we can see here in this diagram on the right-hand side, the additional information we get when we measure the flow velocity. So the red line here shows the water level of the river, the sharp increase of the flood. And we see the blue line and the flow velocity of the river. And the flow velocity increases quite earlier, yes, just in this case, one hour before the water level increased, the velocity increased. So here we have now an additional hour, a complete hour, 60 minutes to give out a warning and to evacuate any potential danger zone. So knowing the flow velocity besides the level is a very good idea and very important in risk warning. So, yep. So why do we want to get the RQ measurements? Because we have limits with the conventional measurements, and especially during flood conditions. Manual measurements are not possible during flood conditions because you have trees, flotsam, and all the like in the river, which can destroy your instruments. And you can't apply expensive methods like an ADCP boat. This would be much too dangerous, too costly if any accident would happen. And during floods, you usually don't have any personnel available that could do the measurements because these people have to do other things. They have other tasks. And extrapolation of the discharge curve is very difficult because you have very rare water levels at this height. So that's why we want to use contact-free RQ30 instruments, which we install above the water surface, safe from any flood and safe from any damage. So going back again to our product portfolio, we are going to focus on the hydrology part, and I will show you the different instruments we have available for application. So on one hand side, we have non-contact radar systems, the main focus of our talk today. This is comprised by stationary RQ30 systems containing a velocity sensor and a radar level sensor. A similar instrument, the RQ30 ADMS, which is a mobile instrument that also contains a data logger and batteries, so it can be deployed very quickly, installed on a bridge, and just started, and we can record the measurements. Then we have a mobile RP30 system, which measures the flow velocity of a river in a high resolution. Then we have velocity sensors only. If you already have a level sensor available, you can combine it with a stationary RG30 velocity sensor. And besides these contact-free sensors, we have tracer dilution methods on offer, which are the TQS and TQF instruments. So the RQ30, the general stationary discharge sensor. Here we have an image of an application on the Rhine River in Austria. Here underneath the bridge, an RQ30 is installed, and it looks towards the surface for velocity and level sensors. It has a real-time output of velocity, level, and of course discharge. As it is mounted on the bridge and not in contact with water, it is maintenance-free. It is not affected by flooding, turbidity, or any flotsam on the water surface. It is easy to install. We can just install it on the bridge railings, for example, or with a little bit more work underneath the bridge to be safe from vandalism. And also here we have different models available for different levels and different setups which we encounter in the real world. Then a brother of the RQ30, the RQ30 ADMS. As mentioned, it has an integrated data logger, an MRS7 data logger of summer mist technique as well. It has a GPRS data modem for remote data access and readout of the data, and an integrated battery as a power supply. And it can also be equipped with a solar panel, like shown here, a solar panel and the sensor here, down here. And we have a complete system in a very compact housing, ready for deployment within minutes or a few hours. Then we have the RP30, the radar velocity profiler, here attached on the bridge on the Rhine River as an example. It's a non-contact mobile velocity profiler to get accurate information of the velocity distribution across the entire river. It uses the same sophisticated hydrologic model as the RQ30 for the discharge calculation, and it is ideal for velocity measurements during flood situations, because we get a very precise velocity profile across the river at high water level. And we don't need a fixed installation if we just want to get the information at very high water levels. And it has the advantage, it can be also applied on cableways, and it is does not require a bridge where there is no bridge available. Then, as mentioned before, we have another section or another product range of discharge measurements that are based on the tracer method. And we have two instruments here available, the TQF and the TQS. The TQF is a tracer system based on a fluorescent tracer, like here, the green colored substance that is used. It is an easy and quick discharge measurement system for very rough rivers that don't have a defined cross-section like this alpine river we see in this picture here. And this method can also be used as a reference measurement for rivers that might be difficult to measure, and as a reference for RQ30 or other discharge measurements. And especially the TQF, as it does require only a minimum amount of fluorescent tracer, is ideal for bigger rivers and flows where the logistics might be difficult. On the other hand, for smaller rivers, we recommend using the TQS, a tracer that is based on a salt tracer dilution. And it is an easy and quick method to the discharge of small rivers with rough flow conditions, like this one here. In this case, you probably need about 1-2 kilos of a salt tracer to measure the discharge in this case. Okay, besides our dedicated discharge measurement systems, we have systems that only measure the velocity or the water level. So in cases where you're only interested in the water level or the flow velocity, or you already have some instruments available, you can use these as a supplement and get a complete discharge measurement system. So, and these are the so-called RG30, the velocity sensor, and the RL15-120, the radar level sensor. The RG30 has the same velocity sensor as the RQ30, and you can apply it in the same way as an RQ30, but just get the flow velocity. And you get continuous measurements of the surface velocity from 0.1 meters per second up to very fast flowing rivers with 15 meters per second. It has the same features as the RQ30. It is maintenance free. It does not require any minimum of water level, and it is not affected by flooding, turbidity, or flotsam. And our level sensors cover a wide range of levels. So we have instruments that cover a range up to 15 meters, 35 meters, 75, or even 120 meters of water level measurements. So we can install it on very high bridges and measure the water level accurately. You can integrate the water level sensor in any other system. It has a 4 to 20 milliamp analog output or an SDI12 option available to connect to a data logger directly. And finally, we have the ultrasonic water level sensor compared to the radar sensor I have mentioned before. It uses ultrasonic signal to measure the water level with a ceramic membrane. It has a very high pulse output and is the best choice during cold conditions with heavy rain and heavy snowfall. So you would choose this instrument in such conditions. It has a measurement range up to 10 meters and an extremely low power consumption. So to give you more details about the RQ30, what can we do with it and what does it measure actually? So the RQ30 is ideal to measure discharges when we are also interested of additional situations or additional effects on the river. So different dynamic processes in a water body comprise hysteresis effects, a change of the riverbed, recognition of vegetation, and change in the flow condition from super or subcritical flow. And also in some in some parts, tidal effects. So I want to show you here some examples of these different processes. Here, the effect of hysteresis. We have here a plot with the flow velocity in green, the water level in blue, and the discharge in black. So if we focus now on this part here to get a better idea of what is happening here. So here we have the water level in blue, and we can see if here the two spots we have the same water level. Here the water level increases, it reaches a peak and then drops again to the initial level. And these two spots, they have the same water level. But at the same two spots we have different flow velocities. So when the water level is increasing, the velocity is quite higher than the flow velocity when the water is retreating again. And also the same is true for the discharge. At the beginning of the flood event, we have a higher discharge, and at the end of the flood event, we have a lower discharge, although the water level is the same. And this is the so-called hysteresis effect. And on the curve here, we can see this effect. So at the same water level, we have different flow velocities depending on the situation when the water is rising or the water level is falling again. Another effect is the change of the riverbed. So if you have sedimentation in the riverbed or you have floods where the riverbed is eroded. And again, we have a plot here with velocity, water level, and discharge. And we'll focus on this part in the graph. Here we can see the black and red lines are the water level, and the blue and green lines are the velocity. And if we look now at the rating curve, or the rating curve, we see that before the flood is happening, or during the flood, the rating curve is the black one, and after the flood, when the riverbed was eroded, there was a shift in the rating curve, and now we are on the red dots here in the rating curve. And looking at such a graph, we can decide, is there a change in our riverbed, and do we need to renew our our cross-sectional profile survey or need to apply any other measures to get to real accurate discharge again. Yeah. Also, another effect is the vegetation growth in some brooks or rivers. Here an example again, we have at the beginning or in the spring, the water level velocity increase and decrease at the same time. So the lines are essentially parallel. And later on, the vegetation on the ground grows, and we see that the water level increases while the velocity decreases. And this continues on and on when the vegetation is growing. And once the vegetation is removed at this point here, the velocity and the water level go back to the level before, which we had before the vegetation growth. And if you look at the discharge measurements are essentially constant during the growth of the vegetation and after the removal of the vegetation. So measuring flow velocity and water level takes care of the effects we get of the vegetation growth within a river. And finally, we have the tidal effects at some shore regions. Here, for example, is shown what this looks like with a river of about 50 meters wide and a tidal range of about 4 meters. Here we can see the instrument, the RQ instrument installed at the bridge, and it observes the flow when we have low or high tides. And here in this graph, we can see the velocity against the water level, and this is a typical curve showing the influence of tidal effects on our discharge. Okay, now I will show you a series of pictures and deployments of the different instruments. Yeah, as mentioned before, we have no installation underneath the water surface. The construction or installation is easy, like we see here. We have a pole attached to the railings of a bridge. At the bottom is the sensor, and at the top the logger cabinet, and it's fast and easy deployed in this application. And it runs year-round. If you have a proper power supply or an autonomous power supply with solar panel, the system runs independently. And you have mounting heights between 0.5 and 35 meters. It's independent of the flow direction. You can install it on either side of a bridge, depending on the river conditions. You can install it underneath the bridge. You can have a fixed or a mobile installation. If you use a mobile installation, you can apply our ADMS system, which has the data logger already integrated. Okay, here are some examples for mounting options. One very or pretty expensive option is a turnable crossarm protruding from the river edge into the river, and here at the very tip the RQ would be installed. Or here an installation underneath the bridge to make it safe from access of other people's. So you can use a crane like this and install the sensor underneath the bridge. Or here, the same sensor within a stainless steel housing in sewage treatment with a canal like this one, measuring very low and very high water levels with the same instrument. Here on the bottom right side, a more economic installation with a little cross arm. Here the RQ30 instrument, and as soon as it is fixed to the cross arm, we turn it and it shows out to the river and can be used for discharge measurements. Here are some nice installations in Austria, one close by on a mountain river, and the bridge here, the RQ30, installed together with a solar panel for autonomous operation. Here on a very rough river, again mounted on a bridge underneath the surface, so it is safe from access. One example in Malaysia, where we have used a cross arm to hang out the sensor over the center of the river, so that we don't measure too close to the edge of the river. One example in Switzerland, a very rough mountain river. Here the RQ30 attached to the bridge with a big solar panel for autonomous measurements, and in the middle the logger cabinet with an MRL7 data logger. Here an example in Turkey with an irrigation channel, again an autonomous system with the RQ30 down here, a solar panel up here, mounted to a bridge. Or here an example in Italy for a water channel, the RQ30 attached to a pole, and this again attached to a turnable cross arm that protrudes from the river's edge and over the river. So here an example with a cableway on a river that is very hard to access. The ropes were installed over the river, and the cableway was used to hold the RQ30 here above the river, and the instrument is able to compensate for any swinging of the instrument and still get accurate flow measurements with this setup. Here an example in Africa of an irrigation channel, again with an economic tripod and a cross arm that is holding the instrument, and the instrument looking upstream into the river to get discharge measurements at different water levels. Again, an example of a cableway installation. Here we can see the RQ30 attached to a structure that is then slipped out along the cableway into the middle of the river for discharge measurements. The instrument we can see up here. Here an example in the Himalayas where the RQ30 was installed underneath a railway bridge, or here again on the right-hand side, sophisticated installation on the Rhine River here in Austria, where there is even a stairway to access the instrument on the bridge. Yeah, and here an example that installations on rivers sometimes might be dangerous. So still having an instrument above the water surface helps us to avoid dangers of any unexpected kind. Okay, finally, I will just give you an overview of all the sensor types of the RQ family. We have the standard sensor. The standard RQ sensor is the RQ30 that has a measurement range for the water level up to 15 meters. We have versions with 35 meters and 75 meters water levels. And with the A indicating, we have the option for an analog output of 4 to 20 milliamp analog output. Then you get the same instrument in a stainless steel version for application in sewage treatment plants or the chemical industry. Then we have some special sensors, the ADMS, the sensor that is also equipped with the data logger. It has the same ranges, 15, 35, and 75 meters level range. Then we also have the RQ30D available. This is a special version for very wide rivers. If they are a couple of 100 meters wide, you could apply this instrument, and it uses one RQ30 that measures the water level and the flow velocity, and it is connected to several flow velocity sensors that are mounted above the river in different positions to get very large discharge flows from large rivers. And finally, we have the RQ30L that can be used with an external level sensor. So if you already have a level sensor available, you can use this dedicated instrument to get a full operating water discharge measurement system. So what do you need for deployment of the RQ30 instrument or any other instrument? You need to select the correct sensor. You need the right level sensor range. Do you have just water levels ranging from, say, 0 to 4 meters or up to 20 meters? Then you have to decide which instrument you use. You need to select a good installation site. And what this comprises, we will show you within one of the next lessons, where it gives you some detailed information, which site is good for a permanent measurement or which sites you should avoid. And then you might need some permits to set up a discharge measurement system, depending on where are you in your country and what are the requirements. Then you have to pay attention to the infrastructure. What kind of power supply do you have? Do you have main powers available, or do you need solar power? Do you have a switch cabinet? Which kind of data logger and data transmission do you require? And you need some sort of structure, some sort of mount to attach the RQ30 correctly. And then finally, you need detailed information about the cross section. So you need to know how the river looks like. What is the surface of the river bed? How deep it is, how wide it is, and what is the roughness? And to do this, you need a reference point. You need to decide where to put the radar sensor, and you need information about roughness. And also this topic here is covered within one of the next lessons with detailed information about a survey of the river cross section and how to get your profile ready for the RQ30 instrument. So thank you very much. So much about an introduction to the RQ30 instrument and its applications, its versions. And within the next lessons, we will give you information about the detailed topics, how to set up, how to install an instrument, and what do you need to gain a cross-sectional profile. And if you have questions now, please post your questions right now, or you can later on send us some email or request information, and we will be happy to answer them for you. So thank you very much again.
Okay, thank you very much, Johannes. So basically, we have now time for the Q&A. So please post your questions down in the chat so we can answer them. As Johannes told you, this was basically the warm-up to know the sensor, what is the sensor doing, where is it working, how is it working. And tomorrow we are going more into the topic of getting the cross-sections on paper, on Excel, what possibilities are there to input a cross-section into QCommander. In the next one, we are actually going to input it into QCommander in all the different ways which are there. And the session after that, we are going to do a little bit of site collection, site survey and site discussions, where we see which sites can work how and how good. And then we have also a last new webinar where we go a bit more into the depths of advanced setting up the RQs and troubleshooting. So if there are any questions, please post them. In the meantime, Johannes, one question was, how much time do you approximately need to set up an RQ?
Take a standard RQ30 system. Setting up or installing it is a quite easy task. So if you would attach it to a bridge, you take a couple of minutes. And to have a larger installation like a cross arm, you probably need half a day. And the most work intensive task is to get the cross-sectional profile. But this is instrument independent, so just setting up an RQ system is done within a very short time, within an hour or maybe a couple of hours, depending on the structures you have available.
Mm-hmm. Another question was actually, how difficult was it, or what kind of mount do I need to fix an RQ to a bridge, to an arm? We have seen quite a lot of arms. How can we fix the RQ to these arms, and is it included?
What is included with the RQ30 is a bracket that has U-bolts with it. So you can attach it to a tube with, if I remember correctly, up to 60 millimeters diameter. So you can connect the RQ30 directly to a tube, and that is included. And you can attach this tube to a cross arm, or you can attach it to a bridge. And yeah, you need to provide a structure like a bridge railing or a cross arm by yourself.
Okay, thank you much. Another question was, how long or what is the maximum length of the cables we can connect to an RQ?
This depends on the signal type we are using. So if we are using, or if you read out data by RSA45, we are restricted to a couple of meters. And if you using SDI 12 as a protocol, you can have much higher lengths. You can go up to 100 meters cable length or even beyond.
Mm-hmm. Okay. Until now, there are not more questions arrived. So I assume that there are no questions anymore. As Johannes said, if you have any questions, please let us know. Send us an email to office.ch office@sommer.at. We are happy to answer all the questions you might have. As Johannes said, we have tomorrow the next webinar covering the surveying topic of the cross-section. And on Friday, we have the Q Commander session, how to handle Q Commander, how to handle profiles in Q Commander. So we are looking forward to seeing you there and welcoming you there as well. Please join us for this journey about the RQ. Exactly. So now an additional question did arrive. How can we make profile for pipeline installation? That's exactly the topic for tomorrow. How can we make the profile? How can we do a profile? It's actually a quite easy one. We have for pipelines, for open pipelines. So we need some open spot. A pipeline is a circular shape. We just use the profile section inside Q Commander and we add a circular shape with the correct diameter, add the radar position, and we are already done. So that's a really easy task. We will see that tomorrow, how we can do that, and on Friday. That's exactly the topics of the next two sessions, where we see how to make the profile, or how to get the profile, and how to enter the profile into Q Commander and download it to the RQ. So please, for this question, please join us tomorrow, and you will get all the answers you're looking for. Okay. In this case, if there are no questions anymore, you also can raise your hand and you can ask them if you like. There's a raise your hand button on your control bar as well. So okay, you just have to unmute yourself and you can ask the question. Ganesh, you had a question? Please just unmute, and you have to unmute. So Ganesh, you can unmute yourself and ask the question if you like. Okay, in this case, we wish everybody a very nice evening, very nice afternoon from our side. Thank you much for attending. We see us tomorrow. Have a good evening and good afternoon. Bye.
Thanks. Bye-bye. See you tomorrow.